This is Geometry, Unit 3.4a. We're talking about proofs about lines and angles. This is day number 1. We're going to be talking about adjacent, complementary, and supplementary angles. So the first thing we have to talk about are what are adjacent angles. And they are angles that are not overlapping, so they don't share any interior parts. And they have to share a common vertex and side. So in our figure over here, we notice that this is not adjacent. They do not share the same vertex. They do not share a side. But if you look over at the next example, you'll see that there's an angle, and its interior is over here. And here's an angle. Are they overlapping? Is the blue and the pink overlapping? Not at all, so they don't overlap. They do share the same vertex. And the pink and the blue do touch each other. They do share a side. They have to share a side and have a common vertex. We don't usually have a statement for adjacent angles. If you read this one, it talks about vertical in here, where this doesn't belong here right now. So let's not get confused on where that is. We're going to talk about vertical angles in the future, but it doesn't come into this location. So those are adjacent angles. Complementary angles. Now this is important for us setting up proofs, for answering many different geometry questions that you will see. Complementary angles are two angles. It cannot be three, and it definitely can't be one. It has to be two. That add up to 90 degrees. They don't have to be adjacent, in other words. They can either share the same vertex or not. It doesn't matter. So let's see. This is an example of complementary. They're sharing the same vertex. They add up to 90. You could say that these two sides are perpendicular to each other. That adds up to 90. The two sides of the angles are going to be perpendicular to each other. That's another vocab word. Or they don't even have to be adjacent. They don't have to have the same vertex. They don't have to share a side. They're just two angles somewhere that add up to 90 degrees. If two are complementary angles, if two angles are complementary angles, then they have a sum of 90 degrees. The shortcut that I would suggest for this is if complementary, then sum of 90. And sometimes we even shorten it to sum 90. But complementary implies that it is angles. Complementary implies that there are two angles. The sum implies that there are two angles. So I'm okay if we keep this as simple as we can. If complementary, then a sum of 90 degrees. We're going to use that in our proofs in the future. With the same concept, we can talk about supplementary. Supplementary are two angles that add up to 180 degrees. So here we have two angles adding up to 180 degrees total. The sum of 150 plus the 30 adds up to half a circle, adds up to a straight line. Or you can have over here, like we have 140 plus we have another 40. Those are two angles that would be considered supplementary. They add up to 180. So the wording that we'll use in a proof is if two angles are supplementary angles, then they have a sum of 180. If supplementary, then sum of 180. That would be even shorter than all those other words. If you have supplementary angles, then they have a sum of 180. That would be a great way to write it also. So let's use those definitions and answer a few questions. What do we have here? We're trying to determine if the angles are adjacent. So it's kind of a yes-no type answer. You got to use the letters. Pay close attention to the letters. Angle BAC. So to do that, look for the B, look for the A, and look for the C. Then we trace those out and we form our angle. Then we're going to look for point C, point A, and point D. Are those angles overlapping? No, they don't overlap at all. Do they share the same vertex?
Yes.
Do they share a side?
Yes.
Share same vertex? Share a side. Yes, they are adjacent because they have those two requirements. Let's come on over and look at letter B. E, F, G. E to F to G. So trace that out. That would be the angle. Then we have HGF. HGF. Do those angles overlap? Those are considered overlapping. That's when they open into each other or they share the same pasture, the same. Okay? Do they have the same vertex? Not the same vertex. That's a big failure. That's part of the definition. They have to have the same vertex. Okay, so right there it's not. Do they share a same side? They do share a same side, but they don't have the same vertex. Not adjacent. All right, this last one. J, N, M. So you want to find where J is, find where N is, and M. So you're tracing that out. There's your angle. You're also looking at L, N, K. L, N, K. Are those considered adjacent? Do they have the same vertex? Sure they do. Yes, same vertex. They don't seem to be overlapping, right? This one opens up that direction. This one opens this direction. They don't share the same pasture at all. Do they share a side? They don't share a fence line. The blue is not actually next to the pink except right at the vertex. Yes, they have the same vertex, but they need to share a side. They are not considered adjacent. This has a special name. Anyone know what type of angles these are? Okay, we'll learn about those in the future. Not sharing same side. So not adjacent. So we know why they're not adjacent, because they need to be next to each other to be considered adjacent. All right, let's come on over here to this one. Let's discuss name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. If you're watching this video at home, pause the video. Try to answer the questions yourself. In class, we're going to have students come up and write these answers on the board. So pause the video. So before we get going, let's discuss what complementary is. All right, complementary starts with a C. You might call it a smaller letter compared to an S. An S is a bigger letter because it's later in the alphabet. C, complementary, is going to be a sum of 90. Supplementary, it's a bigger letter, so it's going to add up to more. It's going to add up to 180 degrees. Two angles that add up to 180. I see a couple angles here. Do any of these angles add up to 180? Do any of these angles add up to 90? If so, what two angles add up to 90? What two angles add up to 180? What two angles are considered adjacent? That's what you want to write in here. Angle and an angle, and so forth. So pause the video, give it a try. So for complementary, we're looking for two angles that add up to 90 degrees. So I see 52 and 38, and I know that 52 and 38, it adds up to 10, that's 8, 9, so that's 90 degrees. So I have angle ABD, that's this one right there, and then I have angle BDC, B to D to C. Those two angles both add up to 90 degrees. Supplementary have to be two angles that add up to 180. I know that the 128 and the 52, this adds up to 10, 7 and 1 is 8. And 1, that's 180. So these two add up to 180. Angle ABD, angle BDE, those two angles add up to 180 degrees total. And then adjacent, the ones that are right next to each other and share a common vertex, the way that we talked about it before was we trace out that angle and we trace out this angle, and we see that they do not overlap, they have the same vertex, and they share a side. So angle, just name the pink one any way you want, BDC, and angle BDE. Those would be two angles that are next to each other called adjacent. So here we are with a question that we're going to see quite a bit. We're going to see this in proofs. So we can write a 2-column proof about it. We'll also have calculations where we just do a math problem that looks just like this. Look at the given information. We know we have these two angles, angle 1 and angle 2, that they are complementary angles. Given the measure of angle 1, we're supposed to calculate for angle 2. So we would want to start out with the measurement of angle 1 plus the measurement of angle 2 adds up to 90 degrees. What allowed us to write that? How do I know their sum is 90? Nothing in here says that their sum is 90. If complementary, then sum of 90 degrees. That's exactly, if we were writing a proof, you don't have to do it in this problem, but if this was a proof, you would say if complementary, because if came earlier, it's in the given, that these angles are complementary. Because they're complementary, I know they add up to 90. What's it called when we plug the 52 in for the measure of angle 1? What do we call that? Substitution property of equality. We substitute it in. So if we were doing a geometry proof, we would write those in here under the reasons. We're not, but we're practicing just the idea at least. What would it be called when I move the number to the other side and calculate the value of measure of angle 2? Subtraction property of equality would be the reason we were able to write that. So we could give reasons where all these steps come from. It's kind of a mini proof. Let's try this one. Here we know that the measurement of angle A, or angle A, and angle B are supplementary. If they're supplementary, we know something. The measurement of angle A plus the measurement of angle B are going to add up to 180 degrees because these are supplementary. If you were doing a 2-column proof, you would say if supplementary, then sum of 180. What do we do next? How do we find out the measurement of A and B? What do we have to do? By plugging in the 7x minus 3, we call that substitution. Substitution property of equality. What's it called when I group these two numbers together? Or these two numbers together? What do we call that? Collecting like terms. Yeah, simplifying sometimes, collecting like terms, any of those are appropriate. Of course, the addition property of equality adds the 4 across, and division property of equality divides the 8 across. Now, let's see if we can calculate this without a calculator. How many times does 8 go into 18? Two times. How much extra is left over? So I like to write the 2 kind of like carrying the 2 or next to the 24. So, or next to the 4 to make it 24. 8 goes into 24 how many times? 3. So our x value is 23. You can do these calculations without a calculator. what are we going to do here for letter A? We see that this is a straight line. One side is 90, so the other side is 90. So we know these two angles add up to 90. So 2x stands for ABD, and 3x stands for DBC, and they're adding up to 90 degrees. So that's a total of 5x. And we have to divide. That's not a subtraction, that's a divide. So 5 goes into 9 one time with 4 left over. So 5 goes into 40 8 times. So it's going to be 18 for x. But you want to be sure to answer the question. The question is, what's the measurement of angle ABD? The measurement of angle ABD was 2 times 18, which was 36. And we're looking for the measurement of angle DBC. That's 3 times 18. That's 54. 36 degrees and 54 degrees. So you need to plug in the numbers if they're asking you for the value of the angle. Okay, pause the video and work on this final question. How would you set it up? What do you see? What do you get? Don't forget to answer the question. So we're going to see that 4x plus 6 and the 11x minus 6 is going to add up to 180 degrees. So we can collect like terms to get 15x. And when we collect like terms, you need to be careful here. This is not 6 plus 6. You're not adding 6 to both sides. You have to just collect the terms. We have positive 6, we have negative 6, so they cross out. This would be division because it's sitting right next to the x. It's 15 times a number. Makes 180. 15 goes into 18 one time with how much left over? We have 3 left over. 15 goes into 18 one time, which makes 15, 16, 17, 18. 3 left over. So 15 goes into 30 2 times. There we have it. You can do these calculations without a calculator.